Welcome everybody to this week's Azure DIY. We're in season 3, episode 2, and I'm super excited this week to have Savenko joining us to present your first slice of Raspberry Pi. For those who are new to joining us here, Azure DIY is where we come together every week to talk on a new topic in Azure and do a deep dive with the experts. A little bit of housekeeping though before we get started here is that we have lots of sessions coming up. Where we had a great session last week from Beck about logic apps, and I'll show you where you can go look at that in a second on our LinkedIn page. And if you haven't seen it, it's worth checking out. This week we have Val, as I just mentioned, and next week you actually have myself and Adam Stevenson talking about serverless Azure in the enterprise. And there's a whole slew of other talks coming this season, so it's worth jumping on our LinkedIn page, which I'll show you where to go here. And you can scan this QR code and you can get a copy of the previous recordings from other seasons, or you can sign up for some of those other sessions if you haven't already. So please join us for the upcoming sessions, and I really hope you enjoy today. As mentioned, a couple of housekeeping rules. First one is that it's going to be the session's recorded today and will be shared afterwards on our LinkedIn page here. And also, we have about an hour today, and we will be asking you to put all of your questions in the Q&A. We might answer some of those as we go, but we'll definitely save time at the end for the juicy ones for about 10 minutes to go through those questions and hopefully finish up on time in the hour in this lunch and learn. So moving on from there, I'll just also cover a couple of updates we like to mention, anything that's new or released or things that are noteworthy. So at the top of our list here, we've got Dapper turned 1 today, which is super exciting. Dapper is our distributed application runtime for building open source, portable, event-driven runtimes that make it easy for developers to build resilient microservices, stateless and stateful applications that run on the cloud and the edge. If that's not a mouthful of buzzwords, I don't know what is, but it's worth checking out. It's a big milestone. It's, I think, 13 releases in to get to version 1 in the last couple of years, and well worth checking out. On a smaller note, we've got a couple of little updates. One is that ARM template specs is now in public preview, so you can have a resource group for all of your ARM templates and manage them in a central place, which is pretty cool. And also we have general availability of soft delete for Azure files, which is also another great way of being able to improve our service on those files and making sure that they're being managed properly. And if you want to check out other updates that we have, you can scan the QR code at the bottom here, and we have a page for Azure and all things that you can go look at and check these updates yourself. That's something we frequently get asked. So moving on from here, without much more chit chat, let's hand you over to Val for our session this week.
Sorry, Val, the same old mistake. You need to come out of mute.
Oh, all right. Well, it's a good start. Hi, everyone. My name is Valeriia Savenko, and as Duncan has mentioned, welcome to the IoT Solution Recipes, your first slice of Raspberry Pi. Who am I? I am the IoT lead for Australia, focusing on IoT, based in Brisbane. I was supposed to say sunny Brisbane, but it was actually raining whole day. So working within the team, focusing on IoT across partners, folks internally and customers, making sure that we are all aligned in driving the same strategy for our customers for IoT to make sure that they get the best outcome when they're deploying an IoT project. On the agenda, we have a few things. We're going to go through current state of IoT, and I like highlighting it because IoT is quite still an innovative sort of service and technology in general, similar to AI and mixed reality. We're going to go through some of the IoT use cases and some of the customer stories that I'm so excited to share. But then going to have a quick overview of the entry points for your IoT solutions and a step-by-step guide, but take it as a few pointers that I'll share with you from some of the projects that I worked with customers for you to maybe focus on whenever you are developing your project for IoT. I like starting with a fun fact. So as you know, we have around 60 Azure regions across the world, and there is one that is traveling or will be traveling at 27,000 kilometers an hour, and will be in a very region on the early 16 times a day. So if you haven't seen it, check out that we recently announced our partnership with HPW to connect Azure directly into space, using their upcoming launch of the Spaceborne Computer 2. And it will deliver artificial intelligence and edge computing to the International Space Station. So I think that's a really cool thing that we are doing that I thought of mentioning. I hope everyone had some lunch. It's actually 12 p.m. for me, but I had a quick bite. And DS3 suggested me that I put a Raspberry Pi on the slide for folks that are maybe not familiar with the Pi. So what is sort of the thoughts behind the talk name? Actually, I'm not so good with the talk's name, and I was lucky enough to co-present with Adam Stevenson, who will be presenting with Duncan next week, so make sure to check out that talk. But we did a talk last year at NDC around IoT and its applications and how it has evolved over the past couple of years. And I guess the talk behind the name was, IoT as a concept has existed for many decades. But I think it started to becoming more mainstream with kind of the cloud adoption in the last 5 to 10 years. So we've seen a lot of customers slowly getting into development of their own IoT solutions for their businesses. And like myself, my very first IoT project was with Raspberry Pi. So if you're not familiar with the board, it's just a simple mini computer that you can connect a keyboard to and a screen and deploy an IoT solution. It has a pretty cool name, which is Raspberry Pi. So this is kind of the background behind the talk. So before we get started, I thought it would just be nice to even outline why are we talking about IoT today. And I really like the research that Gartner has done in the past couple of years to support some of the motions that we're doing as Microsoft and our investments into IoT. So they've done a research, I think in 2020, so that was last year, with the CIOs, and CIOs has mentioned that IoT for their organizations is in the top 5 of the technologies that they are looking into and developing. And that comes from, smaller, simple projects that they're developing and connecting to sort of existing machines to do things like predictive maintenance, to predict downtime and things like that, because that really impacts on their business. And you want to see, what's going to happen in the next couple of months so they can accommodate for some of the downtime from their machineries, as an example. Usually with IoT, from the research, they said that most of all, for most companies, it will take up to 3 years to see return on investment. However, last year research showed that, last year was a very different year for all of us, 2020, and obviously it's still continuing for most part of the world. And a lot of customers are moving towards more of a digital world. So we've seen a lot of really interesting projects coming up from large variety of our customers here in Australia as well. So they're expecting a shorter return from 1 to 2 years now as well. When we look at the kind of the hyper cycle for IoT, and I have personally experienced it myself, another technology that was quite on a hype scale was bots. I think 1 to 2 years ago, maybe 2 to 3 years ago, everyone wants to talk about bots. Everyone wants to talk about IoT. It felt like every customer that I had a chat to, they had a project in mind that they wanted to do. But most of them were doing it because it's fun, right? It's interesting. It's something new. And unfortunately, going from a simple Raspberry Pi project to a full production scale solution, it takes a lot of time and effort in investment because it's all about physical security, its devices, and the scale itself as well. So I guess a lot of customers have seen a little bit of disappointment, but now as they take more of an intentional approach, finding the actual problem that they're trying to solve instead of doing IoT just because it's fun, and don't get me wrong, it's obviously a lot of fun. They're doing more intentional and they're approaching their project with a lot more intention. So I wanted to share 2 customer stories. One is the recent one, and kind of the councils is a passion of mine. I'm working with a few around Australia and helping them within their IoT digital transformation journey and strategy. But one of the recent ones that we've done work with is the city of Whittlesea. So city of Whittlesea, if you're from Melbourne, you probably have heard of them, but they have, they sort of span 490 square kilometers, stretching from the Melbourne northern suburbs to the rural areas, and they have around 220,000 residents. So they're currently undertaking a digital transformation with the use of IoT technologies to help them, provide better services for their residents. Like many council, they've actually set up their own LoRa network. I know Brisbane City Council has set up their own Gold Coast. Sydney folks are doing some amazing things as well. And for the city of Whittlesea, they're collecting now readings like environmental factors monitoring, water level monitoring. They have sensors to do waste management collection, asset tracking as well for different vehicles around the area. So some of the things they're doing is, for example, the waste bin collection. So usually in the way they've done it in the past is it was basically a roster, right, for people to come, put their name, I'll go and empty the bins in this park. But sometimes the bins were either, half empty, so it wasn't really good at their time. So what they're trying to do now is use those sensors to notify folks at the council that the bins have to be emptied. So it's more of a proactive sort of approach instead of just going and emptying all the bins, even if they're half empty. And as well, some of the longer piece of work that they're doing is looking into the environmental sensors and how they can impact planning of parks and areas and sort of resident buildings. So this is pretty cool. The other one, which is a downer rail. So if you're in Sydney, you have probably heard of them. So they're making around 340 million journeys a year possible. So that was sort of happened pre-COVID, the customer story. And the team within the downer is looking after the board fleet within the Sydney to make sure that the trains are operating effectively, they run on time, they clean, and that they can predict the downtime. So what they've done is they try to plug into the machines that are part of the trains to collect all of the data. And they built a project which is called Train DNA, which I think is such a cool name. And think of it as like having a blood pressure reading on the train. So you're aware when the downtime might occur, when you need to maybe do maintenance on the train and things like that. The capacity, how many trains have how many people, maybe they need to send another train. So they're doing a lot of really cool analytics and insights on top of that by getting the data into Azure as an example. So that's another story. They're all publicly available. If you want to read on them, check out on the Microsoft News, you should be able to find them. The other one that I wanted to highlight as well, for example, in retail, and I'm just being mindful of time, we have a lot of customers that are doing a lot of amazing things in retail. And one of the things that I'm looking into is, for example, in-store analytics, right? So that is using cameras around the stores to do inventory management. Sometimes a big problem that they have is misplaced items, and have to admit a few times I came into the store, picked up an item, I saw the queue was too long, and then I decided I don't need that item anymore, and I put it somewhere else on the, in a different area, which is a big problem for them, because then if the next customer comes in and I might have picked up the last item, it means that they won't be able to do the sale. So this is a big problem for them that they're trying to solve using video analytics. And we have a vast range of services that I will speak in a bit that can support solving such problem. When we talk about the entry points for IoT solution, there is a few. So if we start at the lower level down, it all depends on what sort of environment you're currently working with. But if you're familiar with things like Logic Apps, Azure Function, App Service, IoT set of services has a similar capabilities within the platform as a service offerings. For example, Iit Hub, or IoT device provisioning service, Azure Maps, which is a great set of services to help you start it and build that architecture. If we move kind of higher level up, it's your Azure Digital Twins, which you can use not just to model the physical environment, but also we've seen some applications of Azure Digital Twins in banking environments as well, in construction, to sort of analyze the current and predict the future. So we've seen some great application. And then if you go a level higher up, it's our, it's really raining here. It's our Azure Iit Central service, which is fully managed end-to-end platform that enables you to start quite quickly with your solutions. And you don't need to go even into the Azure portal to stand up an application. And really, really high up, I put our partner solutions, which is something that I've been exploring myself recently. And we have a great variety of partners that have built end-to-end solution to support with your use cases within your organization. Finding the right solution, it all depends where you sit on the scale. We do have a variety for them to support your projects, but it goes from, expertise. Do you have development expertise within your team to build out a project? Do you want to have a control, per service, or are you just happy to manage a solution? And pricing, once again, do you want to control it per service, per tier, whether you just want a more predictable pricing? And based on that scale, you can either fully build your own solution with, which we will do today with one of the devices that I have, or you can leverage, let's say, use Iit Central application or one of our partner solutions. So this is kind of the high level, and you can see, option 1 and option 2. So when we talk about Iit solutions, we usually put them in 3 buckets: things, insights, and actions. Things are your physical devices. So for example, in the retail case, that was a camera, right? Camera, doing live video analytics, and then potentially streaming that stream into Azure for AI and ML processing. And then we have the insights. So then figuring out, okay, this is the item that has been misplaced, but it actually has to be on this shelf in this location. This is some of the insights that you're gathering, and what some of the actions that based on that you will then do. So maybe that could be alerting a staff member, hey, an item that is a shampoo, is now in the food section, but it's supposed to be in the shampoo section. So that could be an example of the action. And a successful IoT project has all of these 3 things together. When I talk to a lot of customers, they get too excited about the devices, they get the data flowing, but they don't know what to do with the data. So kind of having an understanding of that end-to-end pipeline and what are you trying to drive, I think it's important when you're embarking on the IoT project. Cool, partner solutions. So let's just get that sneak peek into the demo. Let me just come back and show the partner solution. So for example, if you're looking for a particular solution, go to the app source. Or you can reach out, if you're working with any of our folks internally, like Azure specialists, like 3 is an example, reach out to them to get a little bit more clarity on what solution maybe you can use as part of their your organization. But some of the ones that I've recently explored myself is from, let's say, one of our partner, Lab3. And they're based in Australia. It's a local partner of ours. And they have, for example, a solution called SensorMine. So this solution comes with devices. So the team at Lab3 has also developed the devices to support the algorithm that they've developed. So you can have a read around what they're doing. But this is a great solution for predictive maintenance of the heavy assets, machineries, for example, for mining use cases. So you'll be able to see what is it about, as an example, what protocol it is supporting. OPC UA is a big one when you're talking about industrial IoT and things like that. So you can have a look through different solutions. They've also developed their own AI-driven algorithm to detect faults in the data. So this is just an example. Awesome. All right. So now let's try and build a solution. I will try and do a little bit of whiteboarding. Where's the whiteboard? Let me pull it up. Cool. This is the whiteboard. I'm going to use the iPad. So hopefully we're going to do the whiteboarding. Let me just check it, make sure it all works. So what are we trying to solve? Well, for example, let's have a problem that we're trying to solve. Right now, as you know, we have a lot of transportations of things like COVID testing kits or the vaccines, as an example. And what's important for a lot of different vaccines is obviously to be transported at a particular temperature. You know, some of them are at minus 50 and etc. Maybe the light shouldn't penetrate in the box, and maybe the box shouldn't be tampered with. So the box shouldn't be flipped or moved in any direction. So this is maybe the problem we're trying to solve. And what I want to know, if the light penetrates, I want to be alerted, right? If there is a box and I can detect the light, I want to have a notification sent to me, or I want to see it maybe on the dashboard to then know what sort of effect it caused, or what changes it's made to my testing kits, as an example, right? So we're going to start with the boxes, right? So we will have boxes that will carry the testing kits. And what I need to do is somehow get to, let's say, sensor readings. I need light, right? Maybe I can learn how to spell. I need a light sensor, and then maybe I need an accelerometer, right? So maybe I need a device that would have an accelerometer sensor. So if I tilt it to the right, to the left, and upside down, I'll be able to see the changes in the position. So I need accelerometer sensor. So this is, hopefully I spelled it right. So this is kind of the sensor reading that we're trying to get. So basically, we need to find a device that will be able to get those sensor readings, and I'll put that device onto my box, right? Or maybe inside the box. So that will be our step number 1. Then for step number 2, we need some way to get the data into Azure, right? So we have multiple devices. Some of them might have an MQTT protocol, some may have HTTPS protocol, some might not even have internet connection. So there's a lot of varieties and sensor options that you can have, but we need some type of an endpoint that we can connect from the device to just send the data, right? In this case, if you remember, so we need some type of a cloud gateway. I think that looks like a door that will get that information and send it into Azure. In the Azure set of services for IoT, this service called Iit Hub. So we're going to use this service, connect it to my device, and just stream the data into Azure. So this is step number 1. Then step number 2, I would like to maybe visualize the data, right? So in the case of the COVID testing kits, maybe I just need to be alerted, but in some cases, I want to visualize the data and analyze the data, right? So maybe step number 2, I want to have some type of a dashboard like this. They'll have my data. For the sort of IoT set of services, we have a great service called Time Series Insights, which is a service for you to help you store the data, visualize time series data, query it, save it. There is a really nice way of set of APIs for you to be able to then embed in your websites to pull the data into, if you want to develop maybe custom dashboard. So from the Iit Hub, we're going to send this data into Time Series Insights. So that is step number 1. So this is step number 1. Step number 2. I'm really not good at drawing, but hopefully that that comes across cool. And then the step number 3 that I want to do is that I want to understand when an anomaly occurs. An anomaly for me could be the change in light, right? Before there was no light, so the box is completely closed. What if the box falls, breaks down, but someone tampers with the box, so light penetrates into the box? I want to be alerted. Once again, we have another great service, which is called Azure Stream Analytics, which is a service that helps you analyze streaming data, right? So from the Iit Hub, I want to make another path for the data to come into the Stream Analytics service. And we're going to use a quick Azure Machine Learning function as part of the query in Azure Stream Analytics to look through the stream data. And if there is an anomaly, I want to be alerted. So once we get that anomaly in the good, form of in the good sense of good event-driven architectures. I want to push that message into the Event Hub. So we're gonna use Event Hub. And once again, add that all the data into time series insight. So my time series insight will be my one-stop shop for all of my data, whether it's just the streaming data from the Iit Hub, or if there has anomaly has occurred, I want to see the data maybe overlay with my time series data and see if anyone has tampered with the box. So this is kind of like high level. This is obviously a nicer one. But as you can see, in this case, we're going to use a little bit of a different device, but we have Iit Hub sending the data into the time series insights and using stream analytics for the anomaly detection, also push the data into time series insights. All right, cool. Now let's jump into the demo. So step number one, as I've mentioned, we need to create Iit Hub. So let's do that real quick. I'll just put my iPad away. We need to create Iit Hub. That will be our cloud gateway. Here you can choose resource group. Let's create a new one. AzureDIY Iit and a name. So that will be globally unique. Awesome. Under management, you can have a look for the pricing tiers. In some cases, you just want to stream the data from your devices into Azure. But in some cases, when you have more smarter devices, you want to maybe send commands from your cloud onto your devices. So different tiers will obviously have different pricing associated with it, as well as its capabilities. So for example, S1 tier will enable you to have things like edge support, device to cloud messages. And if you go to one of the basic tiers, it's not going to have that capability, but at the same time, the price will change as well. Let's just choose S1 because I think I have way too many free tiers provisioned, and there is a limit as to how many you can have per subscription. Let's review and create. Hopefully the internet is going to be good for me today. Let's see if it's submitting the deployment. Awesome. That is done. The next service that we want to create, hopefully you guys can see it well. Let me know in the chat if you want to zoom in more or zoom out. The next service that we want to create is device provisioning service. So device provisioning service is a helper for our Iit Hub to provision devices at scale with the same initial configuration. So let's just do that. Iit Hub device provisioning service. And once we start creating it, I will explain a little bit more. Let's say AzureDIY DPS and location. I might have not selected the allocation for Iit Hub. Might have chosen just the default. Cool. Create. Awesome. So while that is provisioning, as you remember, I needed a device, right? I need some type of a device that will have sensors on it, light, and some type of the accelerometer. So if you're looking for a device, either for a demo or you're trying to get something, more production ready, check out this website that is called Microsoft Azure, the Azure Certified Device Catalog. It says preview because we have completely relaunched the website and it now looks much better. It's a lot more clear to see what sort of devices you have and what capabilities they have. So in this case, you just scroll, there is different gateways, there's different sensor devices, MX chip, Rigado is the other cool one if you're trying to do more of a smarter work environments. They have really cool dev kits and edge modules that you can put in your office. As an example, I've ordered one myself, just waiting for it to arrive. But for our demo, I got a new device called Weird Terminal. So I'm going to just use that. So you can scroll down. It has a starter guide, so you can just download it. I think I've opened it twice. You can download and read a little bit more about the device, and a lot of devices will have like a specification sheet that you can have a look through, how to set it up, what are the commands and things like that. So I'll just share it. This is the device. It's pretty simple. It's a simple Arduino board with a few sensors on it and an LCD screen, which is quite handy, so you can output graphs to it and plots and even build the game. It looks like this. It has the 40-pin header, so you can connect to your Raspberry Pi if you want to do like an edge compute, with that serving as a display and a sensor board. Just a few buttons. If you've ever played with kind of the developer kits, you will understand. And it only retails for $30, so it's pretty good price to get started with the device. Now, hopefully, we can come back into our service. So we have to provision. So let's go into our device provisioning service and link our Iit Hub and the device provisioning service together. So whenever the device boots, it will know which particular device provisioning service to connect and what hub it should be sending the information to on its boot. So we'll come to linked Iit Hub. We can add one. And I'm using the same naming conventions for AzureDIY, so it'll be easy to find. AzureDIY and Iit Hub owner. Save. And let's really quickly create an enrollment for this device. So enrollment is a way to group devices for its provisioning. And what it enables you to do is whenever you create a device as part of the Iit Hub, it gives you a connection string. Right? When you're creating devices or provisioning devices at scale, you don't want to manually embed every single connection string into the device. So device provisioning service enables you to do that enables you to provision devices without needing to input into the device the actual connection string. So it's using a general scope ID, which is globally unique, and the connection string for the enrollment itself, but not for the device. So that it makes it a lot more secure to connect. So under individual enrollment, let's create one because I have only one device. It supports a few ways for authentication. My device is a little bit dummy, so I don't really have a TPM module, or it doesn't support an X509 certificate. I'm just going to use the symmetric key, and let's name that device one. This will be the registration ID that we will use, and the device ID will be the ID that we will then pass to the Iit Hub. If you scroll a little bit down, this is the initial device twin configuration, and device twin are very handy when we talk about device management at scale, because they enable you to group devices with the same properties, with the same configuration, and target them at scale. So for example, one of the properties could be the firmware version, right? And different devices will have their own different firmware version, but you might have 10 that will share the same. So you can say, I'm using the job, you can say, hey, all of the devices that are of this type and have firmware version 3.1 as an example, go and update. So device twin enables you to do things at scale and manage the devices. Let's save that. Cool. All right, well, now the fun part. We're now gonna try and connect the device. So maybe I'll do this and the camera, so we'll be able to see. So different devices have their own configuration. So if you have bought this device, the docs are actually pretty good. I got it last week and I was able to connect the device quite quickly. But as you can see through the overview, it kind of helps you to understand how to update the firmware on the device for Wi-Fi, as well as put the Azure Iit firmware on it. So that makes it quite simple. So which is something that I've done to save us some time. What I need to do is I need to now configure the device into the configuration mode. This device is actually holding these 3 buttons. And sorry, that might not be the best view, just trying to Oh, nope, that didn't do it. Just hold the three-button and turn it on. There you go. So now it's in the configuration mode. Sorry, it has my fingerprints. So now it's in the configuration mode. I use Putty to talk to my devices. So use whatever, if you're using Arduino, whatever choice of the tool. So I'll change the font so it's just a little bit bigger so we can see it better. Under session, you go into serial. If you want to know what COM your device is connected, you can check this under the device manager, under ports. So mine is COM4. So I'll just give that COM4 and open. And you can leave the same baud rate because that should be the same. So just click and do help. So here is just telling us how we can connect the device to Azure. So we need three things. We need the ID scope, which will be the globally unique for our device provisioning service. We need the registration ID, as you remember, that was the device one. And we just need to set up the symmetric key. So let's go into this. So number one is symmetric key. I'll just zoom in. I'll zoom out and I'll zoom in back. So it's just easier for me to copy and save that. So that's our symmetric key. They need to set up the registration ID, which is device one. And if we go back into the device provisioning service, scroll a little bit to the side, this is the scope ID, which will be the same for that particular device provisioning service. The only thing that will change is the group enrollment key and the device ID. ID scope. Awesome. So right now we've set up. I have provisioned the Wi-Fi prior to the demo, so that I'm not going to input the key. So now let's reset it. Just pull it down. So now what it's trying to do is to connect to my Wi-Fi. Now it's trying to connect to DPS, and it's connected to Iit Hub, and it's starting sending the messages. A great tool to monitor the messages coming into Azure, and apology if there is background noise, the neighbor is, there's a building being built. A great service to connect to Iit Hub and monitor the messages is the Azure Iit Explorer. So you can download it from GitHub. All I need to do is I need to go to my Iit Hub, Iit devices, shared access policy, and Iit Hub owner, and copy the connection string, add connection, and save. There you go. As you can see, one device has been connected. Look at the messages, and if we do start, so it's gonna hopefully see some events while we are waiting for that to open. Just look if there are any questions. As you can see, it's sending through the accelerometer and the live value. And you can change that. So now I kind of flipped it upside down. Hopefully the light, it's really dark in my room. It was supposed to be a lot bright. I didn't expect it to rain. But yes, so light is now 17. I just flipped the device. So the sensor is inside this part of the device. Awesome. Now that we have device and it's sending the data, this is step number one, success. Step number two is to visualize the data, right? As I mentioned, we're going to use time series insight for it. So let's come into our resource group and type time series insights. And AzureDIY environment name, I'll just leave it as this. I think it pre-populated. Yeah, I think it pre-populated from my previous demos. But what we need to add is the environment name, Azure DIY TSI, and property name will be our partition ID. So we want to partition per device, right? I want to see the data, let's say the light sensor reading per device. How can you find that information? Well, for example, in here, I'll just put it to stop and show system properties. Out of the box, the message that Iit Hub is sending through, it's appending its device name. So I'm just going to use this. I've inputted that before. So we're just going to leave it as is. Storage, Azure DIY storage, and a funky name. So that will be for our cold storage, because time series insight serves as a visualization tool as well as a storage tool. And we just review and create. Oh, I forgot one important thing, event source. So our time series insights will get the data from Iit Hub. So Iit Hub will be the event source. Iit Hub, subscription, Azure DIY. And we need to create a dedicated consumer group for our time series insights from the Iit Hub. Anytime you're connecting something or getting a receiver, you need to create a dedicated consumer group for that receiver from the Iit Hub. We're just going to add that. Okay, hopefully that's all good, and review and create. Awesome. So we'll just give it time. Cool. I'm just looking at the questions. So what is the name of the $30 device? Looks interesting, but did it catch what it was called? Awesome. So it is called Your Terminal. Your terminal. Maybe I just need to, looks like this. You can buy it from Seed Studios. I think this is where I got it. There you go. So $29. I think it's US though, plus a little bit of shipping. But yes, it's called Your Terminal. What was the site for ordering devices? So it's I get my devices from things like Seed Studio, Core Electronics, as an example, and then the other one will be just called Azure Certified Device Catalog. So if you want to have a look, just go there. There's another one which is called MX Chip, which is really good dev kit as well to start with your Iit project. Cool. All right. It's still in progress. That's part of doing things live. Things take time to provision. Do we have? I can reply. Cool. I figured out how to reply to folks in the chat with links. I think I've sent you the one for Seed as an example. Awesome. Cool. Time series insight is provisioned. We're almost there. Let's go to the Azure DIY time series insight instance, and let's go to the Explorer straight away. We just want to see the data. It's refreshing. There you go. Device 1, which is awesome. It already populated the data all for me. Let's look at the light. As you can see, I had the device upside down. Now I turned it the other way around, and I can see finally the data. What you can do with time series insight is that you can visualize the data, right? For example, what is the other one? Like Accelerometer is the other one that I could put on. You can look at the raw data and how you want to visualize the data as well. Don't really have a data science background, so for me, line chart is as far as as I go. But once again, you can overlap the data. You can share it if they're, one is dependent on the other, for example, and you can analyze the data in that way, as well as different ways for charts such as heat map or scatter plot. So you can do that as well. What is cool as part of the time series insight is that you can create types. So if you have multiple devices and they're a little bit different, you can use different types to model the devices. So let's just come in here and let's say add a device. Oh, let's just add a new one. The type asset tracker is an example. And then under variables, maybe we want to add light. So in this case, the data that is coming from my device is relatively simple, and I know it. But if you think, if you are a firmware engineer that is working on the device and you have a data science folks on the team as well, you want to create it in a way that is very understandable for them to look through the data instead of having some random names for the data of the device. Then under the device, you can add a type. Asset tracker, save. Cool. Now we go back. As you can see, device now only see the light. So just a really good way for you to clean up the data and make it more presentable. Awesome. Just checking the time. Let's really quickly jump into the anomaly detection for our pipeline. So we need to create two services, Stream Analytics and an Event Hub. So let's come into this and create one called, Stream Analytics. Great. It only needs a name, so Azure DIY Stream Analytics, Azure DIY Australia East. Here, the cool thing is you can actually export the Stream Analytic job as a container and then run it on the device. So for example, if you're working with the Edge part of the Iit Hub, you're able to export that, write the query, export it, and deploy it to your Raspberry Pi, for example. Really cool tech. Okay, create. Just takes time. Awesome. And then the last one, while that is deploying, let's spin up. Oops. Usually that happens. Let's spin up Event Hub. So Event Hub, if you've ever worked with it, it's quite similar to Iit Hub for that ingestion, data ingestion, high throughput data ingestion service. However, it doesn't have the device management capability like of the Iit Hub. So we go Azure DIY, Event Hub. Really, Azure DIY Event Hub? Shri, was someone else presenting for Iit? That they have already created one. And I go standard and review and create. And create. Hopefully Azure DIY team will be a little bit more understanding and give me a little bit more time. Just takes a little bit longer to provision. Just making sure it's all in check. Just seeing if we have any more questions. And if you have questions after the talk, I know that's what happens with me. I usually reach out after. You can find me on Twitter or even LinkedIn. So basic question, how often is Iit Hub listening to the Edge device? Is that a setting that can be configured? Yes, you can configure that on the Iit Edge side of things, because Iit Edge is designed for disconnected environments. As an example, it's not necessarily listening. It's more or less that Iit Edge is just publishing the messages. So you can configure it how often you want it to do. We also have things like storage services that you can deploy on the Edge, and instead of sort of sending the data from the Edge device to the Iit Hub, you can just store the data into your storage container on the Edge device and then upload it maybe every second week. But obviously that will depend on the size of your device, if it will be able to store all of the data, within the 2 weeks. So you can configure all of that information. Cool, awesome. Now that we have the environment set up, let's really quickly go into the Event Hub namespace and create an Event Hub. So Event Hub will accept the anomaly alerts from the Stream Analytics and push them to time series insights. So let's create an Event Hub. That will be Stream Analytics 2, time series insights, a lot of acronyms, and shorten the words, create, shortening. We'll create it. And we need to configure 2 things. In the same way that we remember, we have configured the consumer group for our Iit Hub. For the time series insights, we also need to add an additional consumer group for time series insights. And then one more thing that we need to configure for the Event Hub is add an access policy so that Event Hub will be able to push, so that Stream Analytics will be able to push messages onto the Event Hub. So we'll just use Stream Analytics and give it all permissions. Awesome. Then one more thing we need to do for the time series insights is add Event Hub as a source. So we have Iit Hub, we just need to add Event Hub as a source. AzureDIY. Let's just make sure I got the naming right. Event Hub 123, awesome. I might not have deleted the one from the previous demo. So we come into the time series insights, event source, and because if I connect it to event source, we're not going to see any messages. So what do we have? This is our Event Hub. Event Hub namespace 123. And then Stream Analytics with time series insights. We're going to use the access policy, and then the consumer name will be, so what, this is time series insights, TSI. And then save. Takes a little bit of time. Awesome. And now if we go back into the the Event Hub, into Iit Hub, one last thing we need to create is dedicated consumer group for our Stream Analytics. A lot of configuration, but this is sort of what you get to explore when you're working with past services and building your application one by one. So TSI, hopefully that is all correct. So what we're gonna now do is using Stream Analytics. So Stream Analytics is, as I mentioned, it's an analytics service that enables you to run queries over streaming data. In this case, we're gonna use Anomaly Detection as part of Stream Analytics. And I'm not gonna reinvent the wheel. I'm just gonna use the Spike and Deep machine learning model sort of under the hood. You can read a little bit more as to what it does, but what I will do is just copy it, and we will go through the query, and I'll explain how it all works under the hood. So if we go to Azure Stream Analytics and query, we'll copy that, but let's add the inputs. So for inputs, we'll have Iit Hub. So Iit Hub is input. Consumer group will be Stream Analytics. And then we'll just leave all the rest as the same. And then outputs will be Event Hub. Event Hub. And we'll use the existing one. Am I out of the time?
Just we've got 5 minutes left, so probably a good time to get close to wrapping up.
Yeah, awesome. Well, it's good that I have pre-provisioned the demo, a working demo, so I can show you guys how it all works. So let me just go back into the working demo really quickly. Just refresh. So in the Stream Analytics job, it's all running right now. But if you look at the query, what you're able to do is you're able to look at all the data that is coming into the Iit Hub, as an example here, and partitioned by ID. And we're just looking into a few samples. And if there is an anomaly within those samples, so let's say the light being 0 and then it comes to, let's say, 10, we will then send an alert into the event hub stream. So maybe I can share that later after the demo, but if we go into the time series insights, I'll just show how it sort of looks. Light and anomaly. Well, that is a lot of data. But as an example here, as you can see, there has been a change in the temperature, and it's going to alert me. I've set up a few rules. Maybe I can send through some of the links after the demo so you guys can sort of follow that along. Apologies, running out of the time. But as you can see, you're able to use that query to determine if the anomaly has occurred. And then using things like, for example, logic apps. So from previous session, from backline session, you can maybe send an SMS as an example, because logic apps has a lot of brilliant connectors. With that being said, I think that's all.
Awesome. That was really cool. Thanks for all of that. We have had a bunch of questions already come through in the chat. There's a couple we've answered. We've got a couple more here. So if anyone's listening now, now's a great time to ask some questions and pop them in the Q&A chat. But let's kick off with a couple here. I've got one at the top. Can we not use our mobile as a device?
You definitely can. There are multiple samples and libraries available for, let's say Android, and you can use that the Azure Iit SDK as part of the application. Let's say if you're building it. I know we're doing a lot of cool things with carriers and Azure in the future. So the next couple of years, if you have time, have read on the Azure Edge zones. So we basically we're working on is having Azure data center at carriers towers, more or less at 5G towers. So you're able to do a lot of things if your kind of devices are, let's say, 5G enabled, and you can do processing at the carriers, at the carriers environment as well. So it's called Azure Edge Zones, but it's still quite a fair bit away, I think, from rolling out locally in Australia. And cool. Then the next one we have
one here. Can we have auto onboarding for devices?
Auto onboarding for the devices. Just wondering if
I think that was around the question you had when you were showing, not having to add connection strings to the device. I think that's when that one popped up.
I see. Okay, cool. I guess with auto onboarding, you still need to somehow give the device the endpoint that it needs to connect to. Obviously, in this case, I did it manually. For example, what I see a lot of customers do is just pre-build the firmware, and then they just upload it to all the devices, and the firmware will have already the kind of the device provisioning service endpoint. So technically will automatically just boot, but you still need to give the device some type of an endpoint to connect to, or maybe build an application in Azure. I remember we did something with a colleague of mine using Azure Functions. So instead of calling device provisioning service, it boots up and let's say calls an Azure function and auto provisions based on some rules. So there's a few different ways and mechanisms you can accomplish that. Even if it's thousands of devices, yes, you can do that. You don't need to give. So you can generate one connection string, but then there is a little code that you can run to. I can't remember what it's called. Maybe I can send that after the demo. You can hash that more or less with the device ID and embed that into your firmware code. So then based on which device it is, it will be able to recognize and then provision. So hopefully that makes sense.
Awesome. Well, I think maybe if we could pull up that feedback slide, if that's possible for you to be able to share. Do you have that on the end of your deck?
Yeah.
And also, I'll just, while we're wrapping up here, please, people, we'll put up a QR code. If you can jump on and leave your feedback, we really value it. That would be fantastic. And also, we have one last question to everyone. If people are interested in a day workshop where you can bring your own use cases and you'd like to come have a workshop with us where you bring your use cases and we run through those, please just leave a comment in the chat and let us know that you'd be interested in something like that. And jump on, scan the QR code as well and leave us feedback. We're really interested in improving, continually improving this. And thank you very much, Val. That was awesome. And the recording will be available on LinkedIn.